We are moving on to section 6.5. This one has to do with rhombi and squares. So we're going to go over properties of rhombuses and properties of squares today. So starting off with a rhombus, it is a quadrilateral with 4 congruent sides. Okay, quadrilateral, it has 4 sides. Rhombus, 4 sides. In a rhombus, your opposite sides are congruent. So if I look at the picture at the right there, all 4 of your sides are congruent. Okay? It's not a square, it's a rhombus. So it is a parallelogram and has all the properties of a parallelogram. Okay, so all those properties, your opposite sides parallel, opposite sides congruent, opposite angles congruent, and diagonals bisecting each other. Okay, all those properties apply to a rhombus as well. Now there are some additional properties of a rhombus. Okay, your diagonals are perpendicular. So where those 2 diagonals meet here, it creates that 90-degree angle. Okay, so all 4 of these angles inside your rhombus will be 90 degrees. Your second additional property is that each diagonal bisects a pair of opposite angles. So again, if I look at my picture at the top there, if I look at diagonal MH, it bisects angle M into 2 congruent angles there. Same thing with angle H, 2 congruent angles. RO does the same thing, bisects angle R into those 2 congruent angles, and angle O into 2 congruent angles. Okay, these 2 are not the same, but these 2 are. Okay, so those 2 next to each other within that angle there. So again, all properties of a parallelogram. So those properties of parallelograms are important. We had them yesterday as well in your rectangle. So you do need to make sure you're remembering those ones for sure. Questions on those properties? Alright, we're going to do some examples then. So in rhombus ABCD, the measure of angle BAC is 32. And we want to find the measure of each numbered angle. Okay, so BAC, this angle here is 32 degrees. It is labeled already in our picture. From that, we can find each of these numbered angles. So to start out, I'm going to find angle 4 first. What does angle 4 have to be using a property, your properties of a rhombus? It has to be 90 degrees because your diagonals are perpendicular to each other. So I know angle 4 has to be 90 degrees. So then I can find angle 1. If I look at triangle ABE, I know 2 angles within that triangle, so I can find the third. I just have to subtract those from 180. So you can take 180 minus 90 minus 32. Okay, that's 58. Okay, so angle 1 right here is 58 degrees. What does that make angle 2 using properties of a rhombus? 58. Because your diagonal bisects that angle. Okay, so those 2 have to be congruent to each other. Okay, then last one is angle 3 right here. So since my diagonal here bisects, this is 32. I have properties of parallelograms, right? So my opposite angles are congruent. And again, since it bisects, all four of these would have to be 32. Okay, so angle 3 is also 32 degrees. Okay, same thing when you had your 58 degrees and your 58 degrees. That opposite angle, those two are also 58 degrees, using properties of parallelograms. Okay, questions on those four angles there, finding their measure? All right, we have some more examples here. So in these next few examples, quadrilateral ABCD is a rhombus. So it is telling us it's a rhombus, so we can use all the properties of a rhombus. We want to find each value or measure. So in number 1, we have angle ABD is 60. So ABD, this angle right here is 60. And we want to find the measure of angle BDC. So if this angle is 60, what's this angle here? 60. Good job. Number 2, if AE is 8, what is AC? AE is 8. It is 16. Okay, so I had AE is 8. I'm trying to find the entire diagonal. Your diagonals bisect each other. That's a property of parallelograms and a rhombus. So this point E here would be your midpoint. So EC is also 8. So if you just add them together, it is 16. Okay, questions on those first two there? Okay, then looking at number 3. Number 3, we have AB is 26. BD, so this entire side or diagonal here is 20. And we want to find AE. For a problem like this, I'm going to use that my diagonals are perpendicular. Okay, meaning these angles here are 90, right? So with this 26, I could form a right triangle within my rhombus. Okay? This 8 isn't here anymore, by the way. So if BD is 20, what would BE be? 10. Now if I know two sides of a right triangle, how do I find the third? The Pythagorean theorem. Okay, so with a rhombus, you are going to have to use the Pythagorean theorem because you do have that, those diagonals are perpendicular. Okay, so 26 is my hypotenuse. That's going to be your C value in your Pythagorean theorem. So we're going to take 10 squared plus x squared is equal to 26 squared. So we have 100 plus x squared is equal to 676. Subtract 100 from both sides. So you get x squared is equal to 576. Then take the square root of both sides to get x is 24. Again, I was looking for AE, so that is only half of that entire diagonal. That's what I was finding when I plugged in x. So AE is 24. Okay, questions on those first three problems? how I used any of the properties to figure those out. All right, then I want you guys to do 4 to 8. You might get tripped up on 7. If you don't understand it, skip it, go to 8, and then come back to 7. Okay? Work together, talk to each other. You don't need to be silent. Yes, you're correct. All right, I'm going to start going through this. So number 4, you're finding the measure of angle CEB. So CEB is this angle here. Well, all 4 of these angles have to be 90 degrees since it is a rhombus and your diagonals are perpendicular. So angle CEB would be 90 degrees. Number 5, you are given the measure of angle CBD. So this angle is 58. And you have to find ACB. So since this angle is 58, this one's 90. You can subtract those from 180 to get this angle here, which is 32 degrees. Okay, again, I got that by subtracting 90 and 58 from 180 to make that triangle. For number 6, you're given AE is 3x minus 1 and AC is 16. Don't set these two equal because this one is only half of 16. Okay, so 2 ways you could do this. You could add 2 of the AE's together. So 3x minus 1 plus 3x minus 1 equals 16. Okay, so both of those sections. Or you could take one of those, and since it's half of the entire length, you could take half of 16 and set it equal to 8. So that section AE there would have to equal 8. Okay, either way, you should get x is equal to 3. Okay, then number 7, you have the measure of angle CDB. So this angle right here is 6y. The measure of angle ACB, this angle right here, is 2y plus 10. And we want to find y. Well, these two angles aren't equal to each other. However, these two angles are equal to each other, right? So this angle here is also 2y plus 10. Well, I have these two angles within this triangle here. What's this third angle? 90. Okay. Now I have all 3 angles within a triangle. All 3 of those angles have to add to what? 180. So I can add all 3. So 90 plus 6y plus 2y plus 10. Set it equal to 180. It is 10. Once I solve for y, you get y is equal to 10. And I was just finding y. Okay, then the last one on the front here, number 8. If AD, that's this side here, is 2x plus 4, and CD is 4x minus 4, we have to solve for x. What do you know about all 4 sides of a rhombus? They're equal. Okay, so I can set 2x plus 4 equal to 4x minus 4. Okay, so all 4 sides of a rhombus are congruent or equal. So you can set those equal to each other. And you should get x is equal to 4. Questions on those problems I had to do? Any further explanation needed? It's not very long. All right, then let's go to the back. Okay, so we just went over the properties of a rhombus. Properties of a rhombus. Now I want to go over the properties of a square. So a square is a parallelogram. Okay, so again, a parallelogram with 4 congruent sides and 4 congruent angles. Okay, so just like a rhombus, all 4 sides are congruent, but you also have now all 4 angles congruent, meaning each angle measures 90 degrees. Okay, so it's a square, all 4 of your angles are 90 degrees. A square is always a rectangle and a rhombus. Therefore, it has all the properties of a parallelogram, a rectangle, and a rhombus. Okay, so all the properties that we have gone over for parallelograms, rectangles, and rhombi apply to this square. So your diagonals are congruent, they bisect your angles, your diagonals are perpendicular here. Each piece of your diagonal is congruent, opposite sides are congruent, opposite angles are congruent. Okay, so all of those properties apply to this square. So we do have a few examples here at the bottom. So in this quadrilateral MNPQ, it is a square with AP equal to 3. And we want to find each measure. So number 9, we want to find AQ. Well, if AP is 3, what is AQ? 3. Number 10, we want to find the measure of angle APQ. So APQ is here. Well, all of angle P is 90 degrees, right? Given my properties of a rhombus, that diagonal bisects that angle. So what would half of that angle have to be? 45 degrees. Okay, then number 11, we want to find the measure of angle MNP. So MNP. What's that entire angle? 90. Okay, all 4 angles again are 90 degrees. Number 12, we want to find PM. That's your entire diagonal. And I know AP is 3, so what would PM have to be? 6. Thank you. Okay, last one, number 13, finding NQ. Well, I just found PM is 6, and I know my diagonals are congruent to each other, so NQ is also 6. Okay. Questions on those problems there? At the bottom, I just have a chart of how to prove a parallelogram is a rectangle, rhombus, or square. So your rectangles, your diagonals have to be congruent, and all angles are right angles. For a rhombus, your diagonals have to be perpendicular to each other. One diagonal bisects a pair of opposite angles, and one pair of consecutive sides are congruent. And for a square, your diagonals are perpendicular and they have 4 right angles. And then it is both a rectangle and a rhombus. Okay, so just some of those properties listed there for you to look at. Any questions?